Hi everyone, this video is Understanding Single Sign-On for Microsoft Teams Developers. My name is Bob German and I'm a cloud developer advocate at Microsoft. And something I've heard a lot from my teammates and our partners alike is that there's a common challenge in trying to figure out single sign-on when developing a Microsoft Teams application. This video will attempt to explain the situation, give you some of the theories so that you can better understand and troubleshoot your solution, and walk you through some common scenarios for single sign-on with Microsoft Teams.
There are a number of reasons to support Azure AD single sign-on in your Teams application. It's easier for users who don't have to juggle multiple usernames and passwords, and it's much easier for team owners who don't have to match all of the M365 logins in their team members with app logins when assigning permissions within the app. It's also easier for Microsoft 365 admins who can control access without having to set up SAML or other federation. It's required for monetization in the Teams store and for the Microsoft 365 App Compliance Program, which is a program that helps enterprise customers to purchase applications with confidence.
So, what is SSO? We know that it's something we want, but do we really know what it means? It means single sign-on, right? Well, yeah. Does that mean one user ID for many applications? So I don't have to remember more than one username and maybe password, okay. Or does it mean that people don't have to type their username and maybe their password? Or does it mean that people don't even notice that they've logged in? All of these different levels of single sign-on are commonly used in different applications, even inside of Microsoft. The Microsoft Azure documentation takes a fairly broad view of SSO, including federation technologies like SAML. That's not true for Microsoft Teams, who has very specific definition for SSO that makes the login experience completely silent and is definitely Azure Active Directory specific. Our commercial marketplace, where you would build a transactable offer that could be sold in the Microsoft Teams store, they have yet another definition of SSO, which is a little simpler than the Teams one, but still requires logging in directly to Azure Active Directory and acquiring an access token, allowing the application to call the Microsoft Graph API. This video will explain all of that, and it will also explain the concepts that underlie any SSO implementation inside of Microsoft 365. I want to start at the beginning because I know a lot of people who are looking to build Microsoft Teams applications have experience on other platforms and may be new to Microsoft 365. Microsoft 365 is a suite of cloud-based applications, some of which have an optional rich client or mobile application, but they all have a cloud presence and are capable of running in a web browser from the cloud directly. These applications include familiar ones like Word, Excel, and PowerPoint, Microsoft Teams, of course, Outlook for email and calendar, and a bunch of others, including OneDrive and SharePoint for file access. Now, what these apps all have in common is that they all share a common identity service called Azure Active Directory, which of course is key to single sign-on in Microsoft 365 and in Teams. If you were to purchase a Microsoft 365 subscription or get a free one as a developer, and I'll put the link on the screen here, what you're really going to get is one instance of Azure Active Directory and access to some or all of these applications, depending on the plan that you have, and the content that users create using those applications. They all go into a tenant, which is a security boundary and an administrative boundary around all of that content and all of your directory information. In fact, the users themselves are registered in that same directory along with their login information, etc. There's also a provision for guest users to come in and collaborate with those users. The guest users have guest accounts inside that same Active Directory, although the login is federated with their home tenant or whatever other identity provider they might use. If you write an application, it also needs to be registered inside of Azure Active Directory so that it can be authorized to access the content on behalf of those users or on its own behalf. This is core to understanding how Microsoft 365 works. Azure Active Directory itself is, well, it's an identity service. It can authorize users who are accessing apps via web browsers, native applications, or daemon or service applications, which may not involve a specific user. And it can authorize access to apps that are running in Azure, in Microsoft 365, of course, or your apps, even if they're not running in Azure, actually, if they're registered in Azure AD. Azure AD can authorize users and apps to come in and access those services. One thing that's important about Azure AD to our enterprise customers, it synchronizes with the on-premises Active Directory service. So users in a hybrid environment can get seamless access to their on-premises and cloud-based assets using Azure Active Directory and Active Directory directory services on-prem. Azure AD provides a consent model. It provides for something called conditional access. So maybe users are only authorized during certain hours of the day or if they are in a certain location. It has provisions for self-service password management, group management, etc. Three core concepts in Azure AD are first, app registration. Applications that want to authorize users, whether they're the client or the service side of that application, they need to be registered in Azure AD. We have resources, which is the services that those apps are using, some of which may be Microsoft services like the Microsoft Graph, which is the main API for Microsoft 365, or your own services. And it also deals with permissions, which are called scopes. So for instance, directory.read scope gives the app permission to read the information inside of Azure AD's directory. Why bother with all this? Well, some viewers may be used to an old school operating system where applications are just files in the file system and users can run any application they want. And once it's running, the application has all the permissions of the user who runs it. This is the traditional method that is used still in a lot of desktop operating systems. The issue is that users have no way of knowing completely what the application is doing. So as this user is playing a game, the game may actually be reading her contacts list and sending spam emails to all of them. A modern operating system, such as any of the mobile operating systems, such as Windows Store applications, and yes, Microsoft Teams applications and Azure AD applications, takes a different strategy. Applications need to be registered and the apps need permissions just as the users would need permissions. Then users and or admins have to consent to those permissions. So we're going to ask that gamer if it's okay to read her contacts. She's going to say that's silly and say no, and the attempt to send the spam emails will be thwarted. So now let me show you a simple example of how this works. I'm going to start out inside of the Azure AD Admin Center. Now you can get to this at aad.portal.azure.com, or you can navigate here from inside the Azure portal or from the Microsoft 365 Admin Center. Now what I'm going to do is access the Microsoft Graph, which is the main API for Microsoft 365, using Postman. In order to do that, I have to register an application that Postman's going to use to get authorization to call the graph. So let me go find that application. I've already set it up and just kind of show you what I have. A couple values I'm going to need to set this up in Postman. One is the application or client ID that uniquely identifies this application. And also, since this is a single tenant app, and we'll talk about multi-tenant later, it's actually pretty simple. But since this is a single tenant app, I need to specify which tenant. And so the directory or tenant ID uniquely identifies this tenant. I've also set up authentication. So Azure AD uses a protocol called OAuth 2.0. And one of the ways of authenticating specifically to a web browser-based auth is to redirect the user over to Azure AD where maybe they log in, maybe they provide some consents, maybe they do two-factor authentication, whatever they do, Azure AD, if they've authenticated, will send an access token or actually an auth code back to the application so that it can get the information that it needs to call the graph. So that redirect back needs to be registered for security reasons, and this is the special magic redirect URL that's used by Postman, because Postman's going to basically pop up a web browser for me to do my login. I also have set up an app secret, which is here, and you can't see it anymore, but when you first create one of these, you have to save it away somewhere safe because you can't see it after that. And I've also gone in and set up some API permissions. So these are all for calling the Microsoft Graph. You can see there's a number of them here. I'm just going to add one. And specifically, I'm going to show this call, which allows you to show what Microsoft Teams a user is a member of, the logged in user in particular. So let me just come down here. I've already looked up this call, and team.readbasic.all is the minimum permission to get that information. So inside of the graph documentation, they're very detailed about what specific permission scopes are necessary to make any one of the calls. Now I'm going to grant consent. See where it says on the right admin consent? It's kind of chopped off, but that's just is admin consent required. That's different from what I'm doing here. I'm actually just granting the consent on behalf of all users because I am an admin. All right, so now I've done that. Let's go over to Postman. And I'm actually using a collection here called the Microsoft Graph Collection for Postman. And you can download it here. I'll put the URL on the screen. And there's some information that I need to now put in here, specifically that client ID and the tenant ID that I had copied from the app registration. So now let's go find that API call in the list. Actually, before I do that, let me come down and show you that I'm going to be authorizing using the browser, using what's called an auth code flow. And there's the auth URL and the access token URL. Both of them have the tenant ID and then the client ID, the client secret, all that information is there. And you can see that it's actually showing up underneath of these special tokens inside of Postman. And I'm going to go ahead now and get that access token. Here's the pop-up. As I mentioned, it's going to have me sign in. And because I've pre-consented as an admin, I don't really need to ask the user for permission. And now Postman gives me this access token. And we'll look at one of those in more detail later. But for now, let's just go down and find the My Joined Teams. So these are the teams that I'm a member of, or the logged in user is a member of. And that's going to be sent in the HTTP header to the graph. And indeed, I'm able to get back a list of the applications. So this is the simplest form of Azure AD sign-in. Now, I'll also point out that Azure AD v2 also has a Postman collection. If you want to go a little bit deeper on how any of these protocols work, you can take a look there and you can actually run it yourself and see how it works. Now, in a few minutes, I'll show you something very similar using a single page application. But before we go there, I want to try to clear up some common areas of confusion that people have when they're learning about Azure AD and Microsoft 365. The first area of confusion is different things called Azure AD. It's really a naming problem inside of Microsoft. There have historically been 4 different products that look a lot like Azure AD. The first is Azure Access Control Services, or Azure ACS, not to be confused with Azure Communication Services, which is also sometimes called ACS. Azure ACS has been deprecated, and we don't really need to talk about it that much. It's a federation service that allows people to log in with Google, Facebook, Microsoft, etc. So if you see Azure ACS on an article or some documentation, that's not the one you want. Probably more confusing is over on the right side of the chart, Azure AD B2C. Azure AD B2C is also a social federation protocol that allows you to build high-scale applications that have people logging in with Google, Facebook, Microsoft consumer accounts, etc. But it's a completely different directory service than Azure AD. So if you see B to C on some documentation, skip over it. It's not going to work with Microsoft 365. It's not going to work in Microsoft Teams. So if we eliminate that, we still have two different endpoints for Azure AD itself. The V1 endpoint obviously is older. That only works with Azure AD, where the new V2 endpoint is quote unquote unified. In other words, your application can work with both Azure AD and Microsoft consumer accounts. The V1 endpoint only supports static consent, meaning that people will consent once to every permission that the app needs, whereas V2 allows dynamic consent so that the app can ask for more permission as the user is using the application. V1, you would program it with an older, now deprecated library called ADAL. V2, you program that with the MSAL library. And they have a unified registration portal. Writing your own services is now easier, so I should update the slide in V2. In general, we're going to be using V2 for everything. But again, I want to point it out because V1 still shows up in the registration portal, and there's still a lot of samples and documents out there that refer to the V1. So in general, you're going to want the V2 endpoint for anything that you do going forward. Now, I've already explained tenants and subscriptions. So this is something that confuses a lot of people when they're getting started. The difference really is that a tenant is that Azure AD domain and the M365 content inside, whereas a subscription is a way of charging for services. So a Microsoft 365 subscription or an Azure subscription, those are used to charge a customer or a partner for the use of Microsoft 365 or Azure. So they are related, but they're really different. And specific, every Microsoft 365 subscription has exactly one tenant, one Azure AD domain associated with it. They always map one-to-one. Whereas many Azure subscriptions can trust the same Azure AD domain. So you could decide to have a bunch of different Azure subscriptions, perhaps with different administrators, different billing, what have you, and connect them all to the same Azure AD domain. So this is just something to be aware of. And also, if somebody gives you an Azure subscription and says, here, use this to build this M365 application, you have to be aware that it might be pointing to a different Azure AD domain, and you might need to switch that. Now, I'll put a link here to an article that explains how to make that change, but I'll tell you that you could also, in doing this, break other things that are already inside of that Azure subscription. So you may not want to reuse an Azure subscription if it requires you to change to a different Azure AD domain and if it's in use for other purposes. Another area of confusion, and the UI has gotten much better about this, is that there are different names for the same thing that are commonly used in our documentation and in our apps, and even in the user interface. A tenant ID and a directory ID are the same thing. They're the same GUID, same globally unique identifier. Client IDs are often referred to as app IDs or application IDs. Client secrets are sometimes referred to as app secrets or app keys. It's basically a password used to authenticate the application's identity. And there's also something that we'll get to later called an enterprise application, which is also called a service principal. And so these things are, hopefully less confusing now that you know that they're really the same. The final concept that confuses people, and this is super important to understand, is the idea of different permission types. Basically, there are two different types of permissions in Azure AD that can be given to apps. The first is user delegated permission, and this means that your app is going to act on behalf of a user. Then there's app permissions, which means that the app is going to act on its own behalf. The different OAuth flows lead you to one or the other of these types of permissions. So user delegated is what I used in my web browser, my Postman example, and that's how I was able to see which teams I was a member of, right? Because I had to be logged in. Your effective permissions under delegated permissions is the intersection of what the user can access and what the app can access. For instance, suppose that Alice has access to Teams 1, 2, and 3, and the app has files.read permission. When the app is running under Alice's login, it's going to be able to read the files in Teams 1, 2, and 3. Make sense? It's just the intersection. It can't write the files because the app only has read access. And it can't access the files in Team 4 in any way because Alice doesn't have access. The other option is app permissions. This is typically used in background services and also to elevate permissions if your app needs to do something that the user doesn't have permission to do, like write to an audit trail or something like that. So in that case, you would use app permissions, and these can only be consented by admins. There's no associated user, and typically you're going to get access to everything in the tenant. So if I had files.read app permission, that allows me to read every single file inside of that Microsoft 365 tenant. There are good reasons to do that, but I will warn you that admins are going to probably scrutinize your request a little bit more if it uses app permissions. There's also something, actually it's out of preview now, called resource-specific consent that allows a team owner to consent just for that team. And that's actually a little bit different than either of these, and I'm not going to get into it in this discussion, but just make you aware that it's available. As I mentioned, Azure AD uses OAuth 2.0 as its protocol. Notice that most of these give you user delegated permission. The only one that gives you app permission is the client credentials flow. So the one that you saw earlier in the Postman demo was auth code PKCE flow that would typically be used for a browser to call a web service. And some of these others are also going to be used in Teams development. I'll discourage you from using implicit flow. You'll still see it in some of our documentation because it wasn't that long ago that was the only option from a web browser in Azure AD, but we now support auth code PKCE. So that's preferred. The problem with that one is that it passes the access token back to the application in the URL of a redirect. So that means that anyone who could maybe see that URL, or if it's getting cached somewhere, that might be able to be reused in a replay attack. HTTPS is mostly going to protect you from that, but that's why we now avoid the implicit flow. And the other one is a simple username password, which is sometimes called user credentials flow or resource owner password credentials, because we have to have fancy names for everything. Really want to avoid this. It doesn't support multi-factor authentication. It doesn't support conditional access. It trusts the application to actually handle the user's password, which could be used again later. In general, you don't want to use this at all, and it really is of limited use in certain DevOps scenarios. So inside of Teams, we're primarily going to use these four flows. The auth code PKCE flow is going to be used inside of the commercial marketplace. So if you are programming your landing page for a user who has just purchased your application in the marketplace, this is actually considered SSO to the commercial marketplace people. So when commercial marketplace says you need SSO to sell in the Teams store, they mean you must support the auth code PKCE flow to log the user in to the landing page after they've made a purchase. That's really different from what Teams means when the Teams folks talk about Teams SSO. If you use that same protocol from a Microsoft Teams app, you can do it, and I'll show you what that's like. The user's going to see a pop-up window, and that's not considered SSO from a Teams perspective. You'll also see auth code flow without PKCE. It's a subtle difference. The bot framework, if you're logging into a bot, is going to use the auth code flow. On behalf of flow is used in Teams SSO, and we have Rabia Williams and I recorded a whole video on that. So I'm going to talk about it here, but we'll go into the code and the details in that other video. And then we have the client credentials flow. So these are the ones that are going to be used the most frequently inside of a Teams application. I want to take a moment here to point out another protocol that you may encounter called OpenID Connect. OpenID Connect is based on OAuth 2.0, but where OAuth 2.0 is about authorizing applications to do things, so you get an access token, which allows you to call a backend service of some kind, web service. OpenID Connect is about authentication. Normally with Teams apps, that Teams app is going to have to call the Microsoft Graph or some other backend API, even your own app's API that is secured with Azure AD, and it's going to use OAuth 2.0. That's why I'm mainly focusing on that in this video. But if you simply want to authenticate the user for your app's own purposes, perhaps to grant permission to certain assets inside of your app, you can use OpenID Connect, which is the same pretty much as OAuth 2.0. The difference being you're going to not request specific permission scopes, and instead of an access token, you're going to get back something called an ID token that establishes the user's identity without granting permissions. So as a Teams developer, as someone building the landing page for the commercial marketplace, you're probably going to be using OAuth 2.0 to not only establish the identity of the user, but to also make calls into a backend API on their behalf.
Now let's use Azure Active Directory in a single page application.
Okay, so let's take a look at this application. The first thing it wants me to do is to sign in. And when I do, you'll see a pop-up flash by. And because I had already previously logged in to Azure Active Directory, it recognized that I was already logged in, and it continued from there without me actually being prompted. This would be considered single sign-on for the purposes of the commercial marketplace landing page that you need to get into the Teams store. It works, and you can see that what it's doing here is it's showing me a list of my files inside of the my OneDrive, and I can come in here and download one of the files and take a look at it. Hey, it's my favorite cat. And I can even upload a file if I want to. So let me do that and show how that works, and that all works fine. So let's go back and look at the registration for this app. So this is a different app ID, same tenant ID. Under authentication, instead of web, I said single page app. With my app's URL is localhost:8080, which is correct. And it says here my redirect URI is eligible for auth code with PKCE, so that's what I'm using in the code. I don't have a client secret. Don't really need one for this. You can't actually, in fact, in Postman, I didn't need it either. I just had it there so I could try other things. In this case of a single page app, you can't really trust a secret in the web browser anyway, so you really just don't even need it here. And then the API permissions, all I have is user.read, which is very limited, just allows me to sign in and read the user profile. So how is it that I was able to access my files list and upload and download files? Well, it turns out that there's another part to this puzzle. So this is where the app is registered, but the consent of permissions is actually stored under enterprise applications. So I could get it, I could navigate there here, but I'll just click into this and it'll bring me there directly. And now you can see that this is the same application. And as a user, I went in and gave it a bunch of different access rights. So I had already consented to having it view my profile, read user files, and have access to my files so that I could do the upload and download part. So what's with that? Let's take a look at the code. So here is the graph code. This is the code that calls the Microsoft Graph. And the first thing I'm doing is creating an auth provider. And an auth provider, this is just part of the SDK. You don't need any SDKs. You could do all of this with REST calls. But in this case,
I'm using the Graph SDK, expects a thing called an auth provider, which has one function in it, get access token. And that is going to call a function over here in auth.js, which gets the access token. So there's a few things going on here. I have this configuration where I've put my client ID. I also have down here the get token function, which is calling this SDK another SDK called Microsoft Authentication Library 2.0 or MSAL 2.0. And it's going to take care of a lot of the details for me. One thing, though, that is specific to this app is this ensure scope function. So this is going to allow me to dynamically add more permissions as I'm running. And that's called dynamic consent. So ensure scope, if you look at the code, all it's really doing is adding another scope, which is just a string, to this array of scopes, which is ultimately going to be used by MSAL to give me the permission. So then if I go back to my graph code again, when I get the user account so that I can say hello to the user at the top of the screen, I'm asking for user.read. When I get the list of files, and here's the call for that, I'm going to ask for files.read. When I want to download the file, I don't need to do anything different, but when I go to upload a file, I need files.read write. Okay, so what if I was to delete this enterprise app? Make sure you're in enterprise apps when you do this. This is also called a service principal, and I find service principal to be a lot more easier to understand. If this was a multi-tenant app, it would be registered in one tenant, like the ISV's tenant, and then the consents would be in all of my customers' tenants. So every customer who granted consent to the app would have an entry under their enterprise applications for another service principal. So it's like a one-to-many kind of relationship. A little trick for testing your consent logic is to just go in here and delete the enterprise app. Make sure that you are indeed deleting the enterprise app and not the app registration when you do that. And now if I come back and refresh the page, you'll see that I'm going to get prompted first for my basic profile information. And if I accept that, I'm going to get prompted again to sign in and read my profile. We're sort of doing it one little step at a time. Now it knows my name, but it hasn't showed the list of files yet. It's waiting for me to agree to read my files, so I'll do that. And then if I want to upload a file, I'm going to get hit with yet another consent to have full access to my file. So it just keeps adding more and more consents into there. Notice that the login button, every time I refresh, I have this login button again. What that's about is it's really about the fact that you need to initiate any kind of a pop-up in a web browser using a user action, right? So that's been around for a while now. It's a standard thing. It's not a Microsoft thing. Web browsers, just to avoid filling people's screens with nefarious pop-ups, you have to click a button or do some user interaction in order for that to work. But let me just try here. I've actually gone and turned off pop-ups in this particular app. So what happens if I come in here and I just add a call to display the UI? Not by pushing the button. Right now it should come right back. And notice that I saw the pop-up momentarily, but I didn't actually have to click the button. Okay, so now let's look at that same exact login method inside of a Teams app, and it does work. It's just the user's going to see a pop-up. So I'm going to use Teams Auth pop-up with Azure Active Directory and MSAL 2.0 as the libraries that I use inside of the pop-up. The advantage of this method is that it works with any OAuth provider. So obviously I'm using Azure AD here, but you could put something else inside of that pop-up that logs into whatever login service you want. And there's no server-side code, so this is a completely static website. The limitation is that the user has to sign in to the tab even though they're already logged into Teams every time they visit the tab or every time that they switch to a new client. So let's see what that looks like. Here I am inside of Teams. This little app shows some email information. It's another very bare bones app, and there we go. So you saw the pop-up. I didn't have to log in. So what happened there was that Azure AD, when it was running in the pop-up, saw its own cookie that was left from the last time I logged in. And it said, okay, I know who that is. And it issued the access token and sent it back via the pop-up, and it worked. But I still saw the pop-up. And the unfortunate part is that if I leave the app and I go back again, I'm going to have to log in again. I'm going to have to see that button, and I'm going to have to push it and see the pop-up go by again. So the reason for that is that Teams is not a web browser. It's just presenting an iframe here, and it's not going to keep the browser session alive or the HTTP connection alive when I leave the tab. So I'm starting over again every single time. If I go over to the mobile client, it looks slightly different, but I still see the pop-up, right? And so this is sort of the reality of this method of logon. So let's take a look at the code. So here I am. This is a React app, so I'll try to explain the React bits away quickly because I want to really focus on getting the access token to call the graph, right? This is the tab, and it's going to call a service, my Teams Auth service, which is part of my project, get access token with these two permission scopes here, user.read and mail.read, which it needed to actually get my mail. If we look inside of Teams Auth service, what it's going to do is it's going to call the Teams JavaScript SDK. There's a call in the authentication namespace called authenticate, which ironically doesn't actually authenticate you. All it does is show a pop-up and then allow a value to be passed back to this application from the pop-up when it closes. So in this case, my pop-up code is under /pound Teams Auth pop-up, right? And then if it succeeds, I'll grab that access token and use it in the graph call. Here's Teams Auth pop-up, and it's going to call its own, another little service I've written here, which is ultimately going to call msal. Here's that msal config, and here's where it's going to actually go in and get that access token from msal. Just like before, it's just the code is kind of structured differently. So yes, this works. Yes, this is the shortest path to happiness for a application that is not using Azure AD. You could get your app into the Teams store using this technique. The mandatory SSO is on the commercial marketplace side when somebody just bought your app. And in that case, it's just going to use normal web-based flow. It's not going to do any of this Teams pop-up stuff to do it. So it's much more like the first example. If I'm in Teams, however, and I use this technique, and particularly if I don't use Azure Active Directory, there are some usability issues that come up. I mean, okay, you can publish that app and you can put people on the app. They're going to always see the pop-up, first of all. And second of all, and possibly more importantly, you're going to create a challenge for anyone who uses that app, particularly for any owner of a team of people who are using the app. Suppose I adopt an app that uses some other directory system, and I want to bring it into Teams, right? So my users are going to be able to access that app from inside of Teams. So the first thing I have to do is go to every user in the team and ask them to sign up under whatever directory service
that app uses, and then tell me what's your login in that other directory service. Then I have to go give all those users permission to see whatever it is inside of the app that using their alternative user IDs. And if somebody new comes into the group, I need to go through that again and say, hey, go to service X, get a login, tell me what it is, and I'll give you permission. Otherwise, they're going to click the tab and see a big access denied from your app, right? It actually gets worse, though. What if somebody leaves the team, right? Is that admin going to remember to go find that matching user account inside of the other directory and remove them inside of your app? Or long after they've maybe left the company, are they still going to be able to use that other ID to log into the app and get at potentially confidential data that they shouldn't really have? This all becomes administrative burden, and those administrators are often going to be part of the decision factor of what app to use. So I will tell you in no uncertain terms that the administrators and the users are both going to appreciate it if you integrate with Azure AD and don't require them to maintain two sets of user accounts, one for using your app and one for using the rest of M365. Okay, so now let's look at what Teams engineering calls SSO. This is Teams tab SSO. The user never has to sign in. They don't see a pop-up, nothing. The user identities, of course, are the same as they would be in Teams itself, so there's no coordination that the administrator needs to do between the two. And you don't need to write a login pop-up page at all, and the user's never going to see one. The limitation is, well, it does require you to write some server-side code to do a token exchange, as well as the client-side code that is your user interface. It only works with one domain per app, so that means your app needs to be hosted in a single DNS domain, and it does not currently work if the DNS domain is azurewebsites.net. So those are kind of the limitations, but this is so much better for the user. Let's take a look. All I have to do, see, I'm done. It's that easy. And now I'm showing all the tokens here, but let me just show that again. I can leave it and go back, and it immediately comes up. And if we switch to the mobile client, it's going to be equally streamlined, right? Just comes right up and we're done. Very, very simple. Now, Robbie Williams and I did a whole video on how to build this. So I'm not going to go into a lot of detail here. Before we look at the code, though, let's take a look at the app registration. It's similar to the one we saw before, except we also exposed an API. And so that involved setting up the scope, and I'll refer you to the other video on the detail on how to set this up. Notice that this URI now needs to show up inside of the app manifest for the app, right? And here it is. That is what allows Teams to give you an initial access token. So if we take a look at that, there are basically three steps. This is the client side. First, we're going to get an auth token from Microsoft Teams. So we're just going to call this function called getAuthToken using the Teams JavaScript SDK. And magically, through the use of that exposed API, which is noted in the manifest, it will give us an access token. However, this token has very, very little permission. It has to really be exchanged for a better token, a more privileged token, on the server side. So the next step is we're going to send this off to our very own server-side code to exchange it for a more privileged token. And when I get that back, I'm going to use that more privileged token to call the Microsoft Graph. Here you can see that it gets passed in to as data in the authorization header, bearer, space, and then the token. That's just the way that all these tokens get passed in. If we take a quick look at the server-side code, here's that /auth/token call. And what it's going to do is it's going to call Azure AD using what's called an on behalf of flow to exchange our weak token for a stronger token that has permission
that we want in the Microsoft Graph with all those scopes in it. So that's, again, I'll refer you to the video for more details, but that's what's involved in building one of these. You really have to include some server-side code, as well as coding these things on the client. And there's also some logic if you want the user to be able to consent in the middle of all this, rather than requiring the admin to pre-consent. That's also explained in the other video. The third option that's specifically for tabs is to use the SharePoint framework to write your tab. SharePoint is a part of Microsoft 365 that is included inside of Teams. So any team that you have is going to have a SharePoint site underneath of it. Now, the main use for that SharePoint site is to store the files that are inside of that team. It's also the same as OneDrive. So OneDrive is really a different user interface on SharePoint. So individual user files are stored there. But SharePoint also has web pages, and those web pages have things called web parts. So if you write a web part, which is sort of it's less than a single page app because it shares the page with other things. It's a partial page app, if you will. If you write one of those and set it up correctly, you can use that as a Teams application. The advantage of that is that you don't have to host the solution at all. You can host it in SharePoint, which is part of your customer's M365 subscription. So you don't have to pay to host it. This is going to work great for some applications and not so much for others. There's no multi-tenant story here. So for a typical ISV, it's not going to make sense, but I still wanted to show it to you because it's the same as the SSO case from a user experience point of view. Because guess what? Under the covers, SharePoint is using that SSO mechanism. So you don't need a login page. It works with any Azure AD secured service, including the Microsoft Graph. And the downsides are that the admin always has to consent. And that consent is often going to be shared with other web parts in the tenant. So let me show what that looks like. That was it. It's a really quick demo, right? If I leave and go and come back, you'll see that it's going to just come up immediately. So that's great. And even if I go over to my mobile client, you'll see the same result. It's just going to immediately come up for me, and click it, and okay, just a sec. There we go. Beautiful. So let's take a look at the code for that. This is it. There's not a lot. The SharePoint Framework, which is how you write a SharePoint web part, it's written in this framework called the SharePoint Framework. It has a graph client factory that will hand you a Microsoft Graph client. It also has an object you can use to call arbitrary other Azure AD services, maybe some that you've written yourself. And you can call that, and it takes care of the authorization for you automatically. So in this case, all I'm doing is calling the graph version of that API inside my SharePoint Framework web part, and I'm getting back the data, and I'm done. The only other thing I need to do is inside of my SharePoint package, I need to declare that I need these permissions. So Microsoft Graph, mail.read, right? And then my admin needs to go in and consent to that permission. And notice that all these permissions, because these are web parts that could share the page with other web parts, they are actually organization-wide. So that's kind of a limitation right now, is that SharePoint has something called isolated web parts that will run the web part in an iframe with its own identity so that it doesn't have to share permissions with all the other web parts. But currently that doesn't work in Microsoft Teams. Therefore, you're going to have to share the permissions with all of the third-party web parts in the tenant. Now, of course, Teams apps can have more than just tabs. So the methods that I've showed you so far, they work in any browser-based or iframe-based Teams app feature. So they would work for a tab, a configuration page, or a task module, where a task module is really a pop-up dialog box, All this is explained in another video that I did with Rabia Williams, which I'll point you to here. In this case, though, I want to show authentication from a bot quickly. And there's two ways to do that. One is with an OAuth login prompt dialog, which is what I'll show now. And another is to use Teams bot SSO, which will be the subject of a future video, but I'll point you to the documentation. So the need for SSO is not quite as severe in the case of a bot, because the login prompt is only shown every few months. The bot framework will maintain a refresh token for us. It will hide that auth dialog until the refresh token expires. So let's see what that looks like for a user. Here I am in my bot, and I'm just going to say log in, and it's going to come in and say, please log in. Okay. So now I have to click the button, and yeah, I have to log in, but I only have to do this when the refresh token expires. So now I can show my email, what have you. And the nice thing is that if I leave it and come back later, even if I come back on a different client in this case, the refresh token is in the bot service. So I'm not going to get prompted again for months, right? So it's not nearly as important for a bot. So the way this works is that in my bot registration, not in Azure AD now, I'm in Azure Services, Bot Services, and this is where I've registered my bot. I need to come in here to the configuration and add an OAuth connection. Now this OAuth connection is for Azure AD, and if I click it, you can see here's the client ID and secret and the other information that I would have used in a tab. But I'll also point out that there are dozens of other services that are supported here. In fact, there's a generic OAuth that you can use if your service is not here, but if it handles OAuth. So this is how you would have your bot authenticate the user if you were not in Azure AD. Or if you just want to keep it simple and use Azure AD, then create a second application. Here's the client ID once again, and add that as an Azure AD OAuth setting to your bot. Then inside the code, and this is the main dialog, there is going to be a child dialog, which is an OAuth prompt dialog. And here you can see the text of please sign in that you saw come up on the screen. And then I'm not going to get into the way that the bot works, but it's basically going to go through all these different steps. And the first step is going to show that OAuth prompt dialog. And then when the user finishes with that dialog, it's going to have the access token that gets sent back, right? And so it's fairly simple. And I'm going to point you to another video, or actually series of videos that I made with another colleague, Aicha Bash, where we go into some detail on this. While these are the most common scenarios, Microsoft Teams also allows its applications to authenticate in messaging extensions and other scenarios. And that's all detailed here in the documentation, and hoping to make future videos to cover some of those other scenarios. So I want to close with a troubleshooting checklist to help you debug the situation if you have any problem with this. The first thing that I always like to do is to start in Postman. If it works in Postman and not in your code, then you probably have a problem in your code. If it doesn't work in Postman, check Azure AD and all the different values and make sure that that's working before you start looking at your code. The next tip really is to inspect the access token itself. And you can do that on a website called jwt.ms. So here I am back in Postman. I'm going to take that access token that I got earlier, and I'm going to paste it into jwt.ms. And what you'll see is that, first of all, these tokens aren't encrypted at all, which is why you have to use HTTPS in order to get any kind of security here. And then you'll see that it's really just base 64 encoded. You'll see here are all these different claims that are part of the decoded token. And, this is a really pretty nice little tool because it'll actually go and explain everything for you if you click on the claims button. In any case, the audience or AUD token, that is the destination for whom this token is intended. Sometimes you'll see a URL like this. Other times you'll see a globally unique ID or a GUID that represents that same application. Either way, it needs to be that same application that you're granting authority to access, in this case, the Microsoft Graph. And if I go down here a little bit, you'll see some other useful things for me to check. First of all, make sure that the app ID matches the app ID that you expect. Make sure that the username is the one that you expect. You can also look at the OID, that is the object ID for my user. So if I was to go into Azure AD and look up my account, it would be this CDA79 GUID. Another thing to look at is the scope. So make sure that you've got the scopes that you expect. And the tenant ID, make sure that that's right. And then you can also check the signature, and you can see here that it's saying that it is issued by Azure AD, and the signature is checking out here. It's green. So just so that we know that the signature part was successful. So that can just kind of help you maybe troubleshoot a little bit of what's going on. Now, check the app ID. If your flow involves an app secret, check that. Make sure it didn't expire. App secrets or client secrets are a lot like digital certificates. They expire after a while. Sometimes if you make a change to an app registration, it might invalidate the app secret. So check that, maybe make a new app secret. You can have more than one, so you can kind of roll them over in your application. Make sure the permissions are correct. Are you using the right kind of permission? App permissions for client credentials flow, or delegated permissions for any other kind of a flow? Were there any admin consents that were required? So if I go back to an Azure AD registration, the permissions that are here, you can see these have all been granted and they're checked off. You can also see this column, admin consent required. So there are some permissions, let's go find one, that are so sensitive that you need the admin to consent. Users just aren't allowed to consent to some of these. So for instance, if I go to sites.fullcontrol.all, this gives access to all the SharePoint sites in the tenant, possibly limited by what the user has access to, but it's still full control. This requires an admin to consent no matter what. And so that's something to be aware of when you're building your application, that you take those into account. Another thing to note, by the way, is that these permissions that are in the registration, these become the default permissions for the app. So if you request an access token from Azure AD with .default as the scopes, you'll get these permissions. If you request specific named scopes and you're in the V2 endpoint, it will actually go in and try to get more permissions potentially than what's listed here. Anyway, you're going to want to make sure that all of those consents have been granted. Is the auth URL that you're referencing the right one for your resource? And if you're using the implicit flow, is that enabled in your app registration? So let me show you where those are. The auth URLs are actually out here in the overview, and you can click endpoint. Here are all the different auth URLs. Typically, you're going to use this one. If you're in the V2 endpoint and you're trying to get an access token with authorization, you would use this first one here. The implicit flow setting is down here under authentication, and it's here. So these ones are checked off. As I mentioned, we don't recommend using this anymore, but if you need it for some reason, it's here. You just have to be aware that these would need to be checked off. So just some troubleshooting tips, because I know this can, a lot of times you're not going to get a ton of information. You might just get an access denied message. They're trying to not give the hackers too many clues as to what's going on, perhaps. So having these troubleshooting steps handy can be a time saver. And I will say that I myself go back to this checklist when I get stuck, and just kind of use it as, did I check this? Did I check this? Did I check this? And usually I can find my issue that way. So thanks very much for watching this video. I hope it was helpful to you in understanding the single sign-on system that's used by Microsoft Teams developers, getting the concepts. Please, if you like the video, please give us a like. And if you want to see more videos like this, please subscribe to the channel and feel free to leave a comment with any special requests that you might have. Thanks very much, and I'll see you in the next video.